functions. What I tried to do on the inverse trig functions is to show you graphically how they are first of all. So I'm going to work a little bit on that tonight and kind of develop this graphing idea. Yes?
I'm sorry, are we only going to go through 8.1 because Canvas was open earlier today?
I noticed Canvas was down for a little bit today.
Yeah.
I'm going to go through 8.1. If you don't have your printout, you can just take something down on paper, okay, for now, because it was not up. It seems like this morning was on there. It was down for an hour or something. There was a message on there too.
Yeah.
Okay, so we'll just.
I mean, I have 8.1, but I was asking if we were going to go through like 8.2.
We won't make it 8.2. If we do, it'll just be barely there, so it won't matter. Okay, this is a pretty long section. Okay, all right. Yes.
I forgot to grab my notebook at the end of the test.
Have what?
No, I forgot to grab my notebook at the end of the test. You don't have to.
Oh, the notebook. Okay. It seems like one of them was left here. Let me see. Is it blue?
Yep.
There we go. Okay, very good. Okay. Okay, so now let's go ahead and get going on this then. Okay, so what we're going to do is we're going to fill out the sine. I see we already know this stuff. We're going to kind of look at the idea of an inverse function, okay? So you know that on a sine, hopefully you have this memorized by now, but if you're looking at a unit circle on a sine, what do? You look at the y value, right? Okay, so let's fill out this chart real quick. So we know the sine of 0, of course, is 0. We know the sine of pi over 2 is 1, and we know the sine of pi is 0, like that, and so forth. If we go clockwise, the sine of negative pi over 2 is negative 1, and the sine of negative pi is 0, like that. So we're going to graph a sine. We already know how to do that, but we have to do this to develop the idea of what an inverse is, okay? So let's go ahead and just plot these points out. I'll have you start at negative pi, and then we're going to go up to pi is the way I'm going to choose to do this one. And you have to have a little bit of knowledge in the background of what inverse functions is. If you took college algebra or pre-calc, at some point you probably learned about inverses a little bit. And then let's go up to 1, down to negative 1 like that, and just sketch out the graph of the sine. So hopefully you have this memorized by now. So we know 0, 0 is a point, pi over 2, 1, pi 0, and so forth, and that'll take us through a cycle of the sine. So I just graphed y equals sine x like that. Now the reason I'm doing that is because what our goal is on this is we're going to figure out what the graph of the inverse sine is, okay? So let's see if we remember anything about an inverse. What you do on an inverse is you switch the points, like x becomes y becomes x. So that's kind of what you want to maybe write down on there is you just interchange. Best way to write this is just interchange the variables. Okay? So what that really means is like in this chart, we just change everything backwards. So like instead of having a point pi 0, if you did an inverse, then that point would go to 0 pi and so forth. Do you guys remember that from college algebra? Did you do inverses? Okay, generally what you do is just switch the variables. X becomes y becomes x, okay? The other thing is, and this is real important, a lot of times students don't remember this. They usually remember the interchanging variables, but there's only a certain kind of function that's invertible or can be changed to an inverse, and that's what we call a one-to-one function, okay? So I'll kind of review with you what you mean by a one-to-one function. That looks a certain way, okay? So how you can tell something's one-to-one is basically the simplest way to do this is it has to pass what's called the horizontal line test, okay? And I don't want to go too deep into that because you have to know a little bit about how inverses work to develop this graph I'm going to do. But let me give you a couple of examples of a one-to-one function, okay? And let me give you an example of something that is not one-to-one and have you write a diagram on this, okay? So an example of a one-to-one function would be y is equal to x to the third. That's one-to-one. Something that's not one-to-one would be y equals x squared. I'm just going to use those two examples because they're pretty easy to show, okay? And the idea would be if you were graphing y equals x squared, Okay, you know, hopefully that's a parabola. So what I want to show you on this basically is this idea right here. On a parabola, we have a point 0, 0, we have a point 1, 1, and we have a point 2, 4, and so forth like that. Now that's not one-to-one. Okay, the reason it's not one-to-one is because it fails the horizontal line test. You guys learn anything about that in college algebra? Okay, you learn the vertical line test tells if something's a function. So basically what happens is if you do this horizontal line test, it goes through 2 points. So anytime that you fail that test, it's not a one-to-one function. And the idea would be on this, if you switch to those points and did this, like this point over here is, this point right here is negative 2, 4. If you switch these points and graph those, you would get a u that's kind of going sideways. And if a u's going sideways, is that a function? No. Okay, so when you do an inverse of a parabola, it kind of roughly looks like that, so it's not even a function. Okay, so that's what happens. Generally, when you do an inverse, what you end up doing is you end up switching the variables so it rotates that in a certain way. So this one with x to the third, let's draw a little rough graph of this, and then this one is a one-to-one function. Let me just write down a couple of points. You have 0, 0, 1, 1, and then 2 to the third is 8, like that. Now, if you look at that particular graph, does that pass the horizontal line test? Yeah, every horizontal line goes through 1 point. So if you actually did an inverse, it would just be rotated. And if it was rotated, it would be a function. The idea is when you invert, your graph kind of looks the same except it's rotated. In a certain rotated and flipped is what happens. So this one is one-to-one because it passes that test. So at a minimum, I want you to just kind of visually know what one-to-one functions look like. Okay, does everybody remember that somewhat? Okay. So what we're going to do with the next page here is we're going to now kind of develop this idea. Okay. So let's go to the next page, and what I'm going to do on this is usually what I like to do is this. I'm going to go ahead and just take a real fast screenshot of this so I can paste this on the page, then I'll show you kind of what we're after here. Okay, so let me paste this in here somewhere. Find a place. Let's paste it down there, and then let me move this over here so you can see what I'm doing here. Okay, so if you're in college algebra, what you learned how to do to make an inverse, all you do is just change those points. They go backwards. So what we're going to do is we're going to fill out a chart for x and sine inverse. Okay, so what we do is we just take these points, and all you want to do is just write them backwards like this. So the first point is now going to be 0, negative pi, and then you're going to have negative 1, negative pi over 2, 0, 0, 1 pi over 2, and 0 pi like that. Okay, now that's what you would do if you're doing inverting something. You would want to do that then. Okay, now let's see if this makes a function or not. The key thing is on this is if we plotted these points on a graph. Okay, one thing about a function, what the meaning of a function is each x has only one y. Okay, that's what we mean by a function. Okay, that's something you generally learn in college algebra. So I want you to look at this real carefully. Okay, look at this x. X is 0. Look how many y's it has. It has pi, it has 0, and it has negative pi. Is that a function? No, that's not a function. Okay, so the idea for a function is every x must have exactly one y. So since that's not a function, what we have to do is we have to redefine it so it is a function. Okay, like that. Now let me ask a question on this. Let me go back to the previous page and just kind of check you on something. Then I'll come right back. So let's look at the sine graph. Okay, look at that sine graph. Is that one-to-one? No, that's not one-to-one. How come? It fails the horizontal line test, right? Okay, but if we could make it one-to-one if we did this. What if we chopped off that and chopped off that? Would it be one-to-one now? Yes, okay, so that's what we're going to end up doing is when we make the graph of this inverse is we actually are going to just sort of chop that off and chop that off like that. So we're just going to ignore some of those points. We're going to define it in such a way so that it's a one-to-one function, okay? So what we're going to do on here. The question is, how do we define it so it is 1 to 1? Well, we define it on the interval negative pi over 2 to pi over 2. So in the chart that I had you write down here, I'm just going to ignore that, and I'm going to ignore that, okay? Now it's a function. Look at this, okay? That x has 1y. That x has 1y now. See, the 0 only has 1y, so that's going to be what we're going to do with that inverse sine, is when we graph the inverse sine, we're just going to graph those 3 points, just those 3, okay? All right, does that make any sense, what I'm doing? This is pretty abstract, but the idea is when you're doing an inverse function, you've got to make the original 1 to 1, because if you don't, then it won't even be a function. Right now, this table is showing something that's not a function. Okay, so let's go ahead and let's graph this then. So what you want to do on this graph that I gave you is we're going to go all the way over to -1 and all the way up to 1, okay? That's what you're used to seeing on the y-axis for a sine, right? Okay, now that becomes x, and you're used to seeing the pi's on the x-axis, so what we're going to do on this then is we're going to go basically to negative pi over 2 like this, okay, and then we're going to go up to pi over 2 like that. Now we're just going to plot those 3 points, okay? Then we'll get what the graph of the inverse sine looks like. So if we plot 0, 0, of course that's going to be there. If we plot, and I need to be looking at these points right here. Actually, I'm looking at the wrong table. So we have 0, 0. We have 1 pi over 2. That's a point on the inverse. Then we have -1, negative pi over 2 like that, okay? Now, what you do on this is just turn your head. Well, you don't have to do this, but I always do this. I tell students take your head and do it sideways and think about how the sine graph would look. I always have to do this to graph this right. So I'm going to just think, okay, that's kind of like a sine wave going through points like that. You see what I'm talking about? So if you turn your head sideways, this should be a little piece of the sine wave. I didn't draw it very good, but that's the idea. It kind of curves through those points like that. So the inverse sine just is this little piece that kind of looks like that. Okay, does that make any sense? Okay, now you have to, the thing on the domain of an inverse sine is from -1 to 1. How do you remember that? What's the range of a sine? Isn't the range of a sine -1 to 1? So remember, when you invert, what are you doing? You're changing variables. So the range turns in the domain. Does that make any sense? Okay, you're flipping variables. Okay, now the range, and this is real important, goes from negative pi over 2 to pi over 2. Okay, so that inverse sine graph doesn't go on forever in both directions like all the other trig function is it looks exactly like that. It has a beginning and it has an end point like that. Okay, okay, so that would be the idea. So one of the things that's pretty important when you're dealing with this is the interval in radians is this. The interval in degrees, of course, would just be -90 degrees to 90 degrees like that. So that's the graph. You're not going to do any graphs of inverse trig functions, but you have to understand the graph to do the main thing that I'm going to teach you in this section. Okay, if you don't understand the graph, the rest of what I do wouldn't make any sense. Okay, so here's a couple of things maybe you've seen in the past is whenever you say, when you see inverse sine, it's written that way. That's one way to write an inverse. The other way that we'll see is we call it the arc sine. So it means the same thing. So we're going to kind of use arc sine and inverse sine interchangeably. They represent the same thing, if you haven't seen that. Yes?
Do you know why they use two different terms? Like why arc? You know?
Historically, I'm not sure on that. It's probably it came from probably people working on trigonometry independently, and some people looked at it that way, some people looked at it the other way. Okay? I don't know the history behind that, but in general, you will see it written either way. They mean the same thing. Okay? Okay, so here's kind of the idea. I'm going to do something on the next page. This, I'm going to see if this little applet works. This may not be any good. I'm going to try it though and see if it works. Okay, yeah, this is what I wanted to show you here. So this is the sine wave you're familiar with. What it's trying to do is it's just taking the points and going backwards, and this is trying to draw the graph of the inverse sine. Okay, like that. And see, this is what an inverse looks like. If you rotate and flip, that's what's happening. So if you imagine rotating that to the right, then flipping it, that's how you get that graph right there. Okay, does that make any sense? Now, is that a function? No. So what we said that we had to do was we had to define that so it is a function. So the inverse sine isn't going to wiggle like that. It's going to be defined on just a certain interval like that. Okay, does that help to see what an inverse is? Okay, it's always just rotating and flipping over the x-axis. You do both. That's what you're doing when you're doing an inverse. Okay, like that. And then basically the graph would be from here to here. Just that little piece right there. From that point to that point, then it's a function. Okay, so that's the idea. Okay, so let's go to the next page. And what I'm going to do on this is we're going to work with finding the inverse sine. Most of this goes back to the unit circle. So we're kind of done with the graph on here. So what we're doing is we're figuring out what the inverse sine of square root of 2 over 2 is. So first of all, what this is doing, you might write a note if you need to. We've actually already done this when we did triangles. This is actually finding the value of an angle is what that's doing. We've learned that already. One of the things that you want to learn how to write out is, and you need to write this down, so what this means, this thing is the same thing as what it really means is the sine of an angle theta is square root of 2 over 2. When you're working with those things, you need to understand they mean the same thing. Okay? So really what you're doing on the unit circle, what you guys are familiar with, is I give you an angle, you give me the value of the trig function, right? Now I'm just doing everything backwards. Okay? So where would the sine be square root of 2 over 2 on this unit circle? There's actually two places.
45.
Right there, because the sine's the y value, right? Pi over 4. The other place is 3 pi over 4. Now there's only one answer to this problem because it's a function. So what you do is you have to pay attention to this range, okay? So basically the two places where the sine takes on this value are pi over 4 and 3 pi over 4, but that's not the answer because it's not in that range. Your answer has to be between negative pi over 2 and pi over 2. So the answer to the problem is pi over 4. That's it. Okay, so I'm doing that backwards. And all these problems that I'm doing now are designed so that they go to the unit circle. Okay, but be sure when you do these problems that you only get one answer. You just have to pay attention to that range. If you don't, you'll mess up. Okay, does that make any sense? Okay, so see, you're just doing everything in reverse is the idea. Okay, okay, let's do a couple of more of these things. Now, one of the things I'm going to do when I'm doing a lot of these problems, I like to do this example too. I'd also like you to write down inverse sine of negative square root of 2 over 2. Okay, like that. And let's do that one also. Now what this means is this means the sine of alpha is negative root 2 over 2. Okay? Now to begin with, where are the two places on the unit circle where the sine's negative root 2 over 2? There, right? The sine's the y value, right there, 7 pi over 4. The other place is 5 pi over 4. Now you only give me one answer to the problem, and it has to fall within this range. So this is a little tricky, so pay attention to this. That would be one place, and that would be the other place where the y value is negative, right on a sine. But neither of those answers are correct. You have to give me the answer from negative pi over 2 to pi over 2. So that means if you're in quadrant 4, you have to go that way. So you got to go clockwise. Now, can you tell me what that would be if it was a negative angle? We end up at 45 degrees. So in radians, what would that be? Negative pi over 4, right? Okay. Every time you have 45 degrees, that's pi over 4. So the answer to that problem is going to be this. Okay. You would end up having theta is negative pi over 4. So this is what's going to happen on an inverse sine, is if that's a positive number, you're going to get a positive angle in quadrant 1. If this is a negative, you're going to get a negative answer in quadrant 4. That's the way inverse sines always work. You either give me a quadrant 1 answer that's positive, or you give me a quadrant 4 answer that's negative. Does that make any sense? Why do we do that? It's all because of this. Okay? You have to make sure that the range is from negative pi over 2 to pi over 2. You can't be outside of that. Does that make any sense? That's the big thing on inverse trig functions, is you got to understand and study that you got one answer and you must pay attention to that range. That's the idea. Okay? Once I do a little bit of this, you'll start seeing the pattern that exists. So let's do a couple more of these and just kind of the same idea. Okay, this one's a half, 0.5 is a half, so I'm going to have you rewrite this as sine theta equals 1/2. We're going to do that. And then we're going to rewrite this one as sine theta equals -1/2. Okay, the unit circle should tell you where you are. Okay, so first of all, on the unit circle, where is the sine equal to 1/2? One place is pi over 6, right? The other place is 5 pi over 6. Which answer is correct? Pi over 6 or 5 pi over 6? Pi over 6. How come? Because you have to fall within that range, okay? Negative pi over 2 is here. Pi over 2 is there. You have to be over here on this side when you're doing an inverse sine. So when you're looking at an inverse sine, don't even look there. Don't even pay attention to it. So the answer to the first one would be theta equals pi over 6, okay? Now, where is the sine -1/2? Right there, okay? It's also -1/2 at 7 pi over 6, but you can't give me that answer, 11 pi over 6, because that's out of that range. So what do you give me? You got to go clockwise, so what would you give? -30 or negative pi over 6, right? Okay, you have to give a negative answer. And once you see this, you will begin to see on these problems, you'll see this pattern. Okay, see how we got pi over 4 and negative pi over 4? Get the same thing. One of them's positive, one of them's negative. That's the way it works. Okay, all right? So if you're doing an inverse sine of a negative, you need to look over here in the quadrant 4, but you got to give a negative answer. Okay, is that solid? Kind of abstract, but that's the idea with that. So let's do one more, then we'll kind of move on and start looking at the other inverse trig functions then. Okay, let's take a look at, let's do the arc sine of -1, and let's also do the arc sine of 1. Now when you see the arc sine, that's the same thing as the inverse sine. So first thing I want you to write down is let's rewrite this as sine theta equals -1. That's what that means. And then write this down as sine theta equals 1. Okay? Now what you need to do is you need to look at the unit circle and you need to find when the y value is -1 and when the y value is 1. So where is the y value -1? There's only one place on the unit circle where that happens. Where is it? Right down there, right? Okay? 3 pi over 2 is not the answer to the problem. Why? Because it's out of that range. You've got to go this way. So what's the answer? -90 is negative pi over 2, right? Okay? Don't use that. It's out of that range. That's bigger than pi over 2. So when you give the answer to this problem, that's going to be theta is negative pi over 2. Okay? Right there. Has everybody got that? If you're down in the quadrant 4 area, you better give me a negative angle. You got to fit in that range. Okay, what do you think the answer to the sine of this one is? Sine theta equals 1. Pi over 2, right. Okay, that's where the y value is 1, so that's going to be pi over 2. So see, there's a pattern to that. It's real simple. One of them's negative, one of them's positive. That's the way inverse sine always works. Okay, one answer and fall in that range. Is there any questions about that? Okay, now I'm going to ask you a trick question here. Okay, arc sine of 2. What this means, you want to write down that what this means is sine theta equals 2. Okay, like this, okay? I want you to look on the unit circle very carefully and look at all of these y values right there. So where is the sine equal to 2? What did I hear someone say? Nowhere? Is that what I heard someone quietly say? That's correct. What is the biggest value that the sine ever hits? 1, okay? So this one is not defined, okay? The thing that you're going to find on this is if you look at the domain of an inverse sine, this number right here, anytime you do an inverse sine, the number that you're working with there has to be between -1 and 1. Okay, otherwise you get like it's undefined. Okay, that's the idea. Does that make any sense? Okay, so you can only do an inverse sine of numbers between -1 and 1 because that's how it is on the unit circle. That's the smallest value of a sine. That's the biggest value of a sine. So you'll never get an angle where the sine is equal to 2. Does that make any sense? Okay, all right. Now let's go ahead and I'm going to put my unit circle. I'll let you just do these problems down here real quick. I will sneak my unit circle down. You can just do these in your head. And let me erase some of this, and you can look at my unit circle and figure these out real quick. Like what I want you to do is just one more case where you're doing an inverse sine of a negative and an inverse sine of a positive. And again, write down the domain and range because you need to know what that is and get that memorized as fast as possible because you're going to use it when we start solving equations. If you're going to take calculus, you've got to know these domains and range because they show up all the time in different situations then. Okay, so I'm going to have you, first of all, just learn to rewrite this as sine theta is root 3 over 2, and then write that as sine theta equals negative root 3 over 2. One of them's going to give a negative answer, one of them's going to give a positive answer. And I want these in radians unless I state that I want them in degrees. Okay, well, let's look at this one first of all. Okay, what are you coming up with for sine theta equals square root of 3 over 2? What's theta? Okay, pi over 3, right? When you're at pi over 3, the y value is square root of 3 over 2, right? Okay, now how about the sine theta equals negative square root of 3 over 2? Is 5 pi over 3 a good answer? No. What is a good answer? Negative pi over 3, okay? When you're down in this quadrant, you have to give me the negative answer. So that's the thing that students do not do well with in this problem often. So the answer to this one is pi over 3, okay? And then the answer to this one, you got to go clockwise. So that's going to be negative pi over 3 like that. Okay, you guys solid on that? Okay, and then get this memorized. The domain of an inverse sine is negative 1 to 1. That's opposite of what the range is on a sine. That's how I remember. And then the range, just get it memorized. That's negative pi over 2, and they both got brackets on it. That's pretty important. Okay, any questions about that? Okay, you're going to use this inverse idea a lot when you solve trigonometric equations. That's part of why you learn this. If you are going to study calculus, when you get into calculus, you work here and there with inverse trig functions, so we want to get a decent background if you're going to take and study at a higher level. Okay, now what we're going to do on the next page is we're going to work with the cosine, the inverse cosine. So what we're going to do here is just kind of go through a same thought process. First thing we're going to do is we're just going to do the cosine real quick. And hopefully you've already got this memorized. So if you're looking at a cosine on the unit circle, you're looking at the x value, of course, right? So let's just fill out the table. We're just doing a cosine to start with. So the cosine of 0 radians is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. If you go clockwise, the cosine of negative pi over 2 is 0. And then the cosine of negative pi is negative 1. Okay, so you already know that, right? So let's go ahead and let's graph that cosine because we need to look at how the inverse is going to work on this. So we're just going to go from negative pi to pi. You want to get all that kind of put together to begin with, and then go from negative 1 to 1 like that, okay? And when you memorize this, this is what I was talking about when we're doing graphs. I always said try to remember the cosine starts high, starts at 0, 1, then it cycles through those points like that. So this is just review of how that cosine graph's going to look. So I'm going to just put your points on there and then sketch out the cosine. Okay, like that. All right, so that's how your cosine goes. Now what we're going to do when we develop the inverse cosine, what are we going to do with those coordinates? We're just going to flip them, just like we did on the inverse sine. Now I want to ask you a question on this before I go to the next page. I said if you do an inverse, whatever you do in an inverse of has to be 1 to 1. Is that 1 to 1?
No.
No. Okay, we can make it 1 to 1 in several different ways. One way to make this 1 to 1 is just to look from 0 to pi. Is that a 1 to 1 function? Yeah, that would pass the horizontal line test. So that's one way. But right now, the cosine by itself is not a 1 to 1 function. So we have to kind of be clever in the way we define that in order to find an inverse, okay? Okay, so let's go to the next page. And now we're going to put together the inverse. We're going to kind of do the same thing with the sine, cosine, and tangent. So I'm going to go ahead and paste that here. So what you want to do on this page is take this table that we just did and just do everything backwards. Okay, so we're going to do this. Okay, we're going to go -1 negative pi and so forth. 0 negative pi over 2, 1 0, 0 pi over 2, and so forth like that. So that's the idea. Okay, now let's see if this makes a function or not. So the question is that we have to ask, does every x have exactly one y? You don't have to necessarily write that down. Let's just see if that's right or not. Okay, let's look at 0. How many y values does 0 have in this table?
2.
That's 2, so it's not a function. How many y values does -1 have? That's 2. It's not a function. That is not a function, and we want this to be a function. So that's not a function. So what we do is on the cosine, we go like this, and this is just a mathematical definition. We define it a certain way. You can't just define it how you want to. I mean, this is the standard way we do this. So what you're going to do is you're going to look at just from 0 to pi like that. Now you've got a function. Okay, every x has one y, so it's a function. Now what I want to show you on the previous page is what we really did on this problem to do this. Okay, and I already kind of talked about this. So on the previous page, that's a cosine. So if we just look at that sliver right there, is that 1 to 1? Okay, yeah, if you just sort of ignore that, and if you look at that sliver right there, that's a 1 to 1 function. So that's what we're going to focus on, is just that piece right there. Okay, let me go back this page here. Okay, so now we're going to go ahead and we're going to graph this. So we're just going to graph these 3 points. So I'm going to go -1 to 1 on the x-axis. My y's are going to go up to pi. So we're going to kind of just plot those 3 points, and then that'll give us a good graph of what the inverse cosine looks like. Okay, so we got 1, 0. Got that point we want to plot. We got 0 pi over 2. And then we got -1 pi like that. Okay? Now, don't just connect it however you want to. You got to turn your head sideways and kind of go like this. That's kind of like the cosine going something like that. I just turn my head to the right 90 degrees, and that's what the graph looks like. That's how I remember that. Okay? So that would be the graph of the inverse cosine now. So what's different on this is the domain is -1 to 1. Now the range, which is the real big deal in here, is 0 to pi. The inverse sine was -pi over 2 to pi over 2. Now it's different. Okay, does that make sense? Okay. All right. Now I want to, before I do anything else with this function, I want to show you something on the calculator. And sometimes this helps students understand this a little bit better. I'm going to just punch a couple of things in my calculator. So I'm going to put myself in degree mode because you'll see it better. And you don't need to do this on your calculator. I just want you to watch this. Okay, if you do an inverse sine, you're going to go inverse like that second sine. Okay, let me show you what happens. If I do like 0.6, notice that what I get is a positive angle. Okay, if I do like the inverse sine of -0.6, look what happens. You get a negative angle like I was showing you, because the inverse sine is defined to give you answers from -90 to 90. Now your calculator is programmed to do this correctly, so I'm trying to program you to do it correctly, you see. Now I'm going to show you what happens on the inverse cosine. If I go inverse cosine of, say, 0.2, a positive number, okay, what I have there is I have 78 degrees. Now let's look at what happens when I do the cosine of -0.2. It has a totally different pattern. What it gave you is a quadrant 2 angle. Okay, what's going to happen on inverse cosines is an inverse cosine of a positive is going to give you a quadrant 1 angle, whereas the inverse cosine of a negative is going to give you quadrant 2. Why is that? Because the range of the inverse cosine is 0 to pi. Does that make any sense? Okay, you got to pay attention to these ranges when you're working these problems out. Okay, now this is not difficult, but if you don't pay attention to the range, you aren't going to do this very well. Okay, so let's do a couple of these with the cosine. And what I want you to do on this number 11, first of all, rewrite this as cosine theta equals square root of 3 over 2. And then write this one as cosine theta equals negative root 3 over 2. What I'm trying to get you solid with is the difference between the positive and the negative, okay? And again, what you have to do on this is you have to pay attention to this range right here. The range is from 0 to pi. Okay, so let's look at the first one. Cosine square root of 3 over 2. You can only look from 0 to pi. So what angle would give you a cosine that's square root of 3 over 2? 5 over 6, right? Radians, okay? What angle would give you, from here to here, negative square root of 3 over 2?
Negative 5 over 6.
Nope. Okay, you're back on the sign now. Remember, we're okay to give answers from 0 to pi. So try again. 5 pi over 6. That's the answer. So you're going to get a quadrant 1 answer and a quadrant 2. It's different than the inverse sine. So the answer goes like this. For square root of 3 over 2, remember the cosine's the x value. So that's going to be theta equals pi over 6. And then for negative square root of 3 over 2, you give 5 pi over 6. Okay, you're allowed to give a quadrant 2 answer. That's it. Cosine's different than sine. It works differently. Okay, does that make sense? So you must pay attention to that range. If you don't, you won't get this right. Okay? All right, any questions about that? Okay, let's work with this just a little bit more then. And as I'm doing these, let's kind of do two things at the same time. Let's also write in arc cosine of negative 1. Again, we're going to just figure out these answers. There's only one answer to these problems. Arc cosine means the same thing as inverse cosine. So you want to write that down. That means cosine theta equals 1. This one means cosine theta equals negative 1. And then you're going to start seeing a pattern on this. So when you do an inverse cosine, your answer needs to be from 0 radians to pi radians. So where do you see on the unit circle where the cosine is equal to 1? At 0, right? Okay. Where do you see on the unit circle where the cosine is negative 1? Pi, right there. Remember the cosine's the x value. Okay, like that. So what you end up getting is the cosine takes on the value of 1 at 0. So the arc cosine of 1 is going to be 0. Okay? And then the cosine takes on the value of negative 1 at pi. So the arc cosine of negative 1 is pi. Your answers are between 0 and pi, so we're good. Okay? Does that make sense? Okay? All right, now the next one, trick question. Okay? Write down, first of all, cosine theta equals negative 3.5. Okay? Now, if you're trying to solve this problem, you're trying to find an angle where the x value is negative 3.5. Where is it? It doesn't happen, exactly. You can never do an inverse cosine of anything that's outside of negative 1 and 1. So this one's undefined. Okay? I mean, after all, what is the biggest x value you ever get? 1. What's the smallest x value you ever get? Negative 1. Okay? So what you have to pay attention on this is when you're doing an inverse cosine, you can only do numbers between negative 1 and 1. That's it. Otherwise, you're going to get an error. Okay? That doesn't make any sense. Okay? Okay, so you guys go ahead and just give the answer to the next two. Okay, I'll leave the unit circle up here. If you have your unit circle memorized, you can pretty well tell what this is. So again, write down this is cosine theta root 2 over 2. And then this one means cosine theta is negative root 2 over 2. So what you're doing is you're giving me the angle where the x value takes on that value. But again, make sure the answer that you give me is between 0 and pi. If it isn't, you're wrong. Period. And that's why students tend to miss these problems. They don't pay attention to that. Okay? Okay, where is the cosine equal to pi square root of 2 over 2? Pi over 4. That's where the x value is that. Pi over 4 is the answer to that problem. Okay, where is the cosine equal to negative square root of 2 over 2? 3 pi over 4. You're okay with that. Don't give me a negative answer. You give me a quadrant 2 answer. That's the way the inverse cosine works. So that's 3 pi over 4. So you always get a quadrant 1 answer and a quadrant 2 answer. when you look at the difference between positive and negative. Okay, that's because it's an even function. That's the reason for that. Okay, is there any question on inverse cosine? You guys get the gist of what I'm trying to show you here. We're just doing everything in reverse when we do inverses. Okay, so now we're going to go on to the tangent, and then I'm not going to do this for all 6 trig functions. I'm going to do it up to the tangent. The rest of the trig functions, I'm going to give you the domains and range and the information. So let's go ahead and let's work this out. So the key thing on this is we're just going to graph the tangent. Okay, so we know the tangent's y over x. So we're going to go around the unit circle looking at 0, pi over 4, up to pi over 2. Then we're going to do the negative ones also. So we're just going to do y over x all the way around like this. Okay, you can do this in your head. So at 0, what's the value of the tangent right there since it's y over x? 0, right? The tangent of 0 is 0. Okay. Okay, go to the next one. Okay, the tangent of pi over 4. What is y over x there? 1, right? Any number divided by itself is 1. So that's y over x is 1. Okay, go to pi over 2. What's y over x there? Undefined. You have a vertical asymptote like we learned, right? Okay, so you have that. Okay, now go to negative pi over 4. What's y over x there? Negative 1. Okay, then go to negative pi over 2. What's y over x there? Undefined. Okay, like that. So what you're doing, you've already learned how to do the graph of the tangent. You're just going around and doing that ratio of y over x like that. Okay? Now let's go ahead and let's graph this. And we're going to kind of get this put together, and this will help us understand what the inverse tangent looks like and what it means. Okay, so we want to get that kind of put together like that. Then we want to go just up to 1 and to negative 1 like that. So we've already learned this. What you learned on a tangent is you're undefined at pi over 2. So we learned there's a vertical asymptote there. You also learned that we're undefined at negative pi over 2. So there's a vertical asymptote there. Halfway in the middle, have the point 0, 0. To the right, you're up 1. To the left, you're down 1. And then that's what we learned that the inverse tangent, or that the tangent graph looks like, is like that. Everybody remember that, okay? Okay. Now what we're going to do is we're going to invert this. So what that means is, if we're going to have an inverse of this, we got to see if it's 1 to 1 or not. Now if you just look at this piece, don't look at the tangent beyond pi over 2, or to the left. Does that look 1 to 1? Yeah, okay. It passes the horizontal line test. So that one already is 1 to 1. Now, what that graph of the inverse is going to look like, in your mind, you would have to think this way. You rotate and then flip, and then you get what that looks like, okay? So on the next page, what we're going to do is we're going to put together the graph of the inverse tangent here, okay? So let me take a screenshot of this real quick so that we can refer to this. Okay, so let's see what we got here. Okay, so here's the idea. Now what we're going to do is just flip these coordinates, all of them. This one, even this one, we're just going to put like undefined there and negative pi over 2. And here we're going to put negative 1, negative pi over 4. Of course, that's still 0, 0. That becomes 1 pi over 4. And that one becomes undefined and then pi over 2. Okay, now let me see if you understand this. You have a vertical asymptote. What do you think will happen to the vertical asymptote? It becomes horizontal. And you learned about horizontal asymptotes probably in college algebra, right? Maybe. Okay, so that's going to become horizontal. Okay, this does make a function. This is a function this time. Okay, when you do that, because if you look at this, just in this piece right here, the 1 only occurs once and it has one y value. So that is a graph of a function. So what we're going to go ahead and do is we're going to plot these points like this. So when you do this, you want to start this kind of like this. We want to put like on the x-axis, put a negative 1. Don't put it at the end. Kind of put it, you know, kind of in there somewhere like that. And then for your y-axis, we're going to go pi over 4 and pi over 2. and then we're going to go down to negative pi over 4 and down to negative pi over 2 like that. Okay, so what our goal is on this problem is get a good picture of what the inverse tangent's graph looks like. When I teach Calc 2, we refer back to this graph periodically here and there when we're working with certain things. So what you want to do is you want to go ahead and that's now going to be a horizontal asymptote. And same thing there, you want to go ahead and do a horizontal asymptote kind of like that. So that's how that goes. Now let's just plot these 3 points right here, and then we'll kind of talk about how the graph's going to look then. So we have the point 0, 0, negative 1, negative pi over 4, like that. Then you have over 1, up pi over 4, like that. Okay? Now if you just turn your head to the right, this is the way I do this, is, okay, I just kind of draw kind of like that, and then you would be approaching those horizontal asymptotes like that. Okay? You're not going to touch the asymptote, but the idea, the way horizontal asymptotes work, is x gets bigger, you get closer to the asymptote, but you never touch it. So that would go kind of the same way like that. So that's what the graph of an inverse tangent looks like. If you look at the domain, it's all real numbers. This graph goes forever to the left and forever to the right, so the domain of the inverse tangent is negative pi to pi. What's the range? It's very strictly from negative pi over 2 to pi over 2, right? Does it include negative pi over 2? No, because there's an asymptote. It'll never touch that. Does it include pi over 2? No, there's an asymptote. So what you have here is you have this situation. So this is the big deal on this, is that's the domain and that's the range. Now that range is different than the inverse sine. The inverse sine was bracket negative pi over 2 to bracket pi over 2. It includes. So you got to pay attention to where those parentheses are. Okay, does that make sense? Now, I want to ask you and see if you guys can kind of think about this in your head here a little bit. I'm going to put this on the chalkboard real quick. Pi over 2, negative pi over 2. What I'm drawing right now is the graph of the tangent that we've learned. Okay, here's what happens when you do an inverse. First thing, it takes 2 steps to get a graph of an inverse. First thing you'd have to do is rotate this thing. If you rotated it, it would kind of look something like that. Okay, if you took that thing and rotated it 90 degrees, you would get this, right? Now, how do you turn that into that? Now you flip it. So what I'm trying to show you, when you do an inverse, it's rotating 90 degrees to the right, then flipping, and that's how you get that. Okay? And that's because you're changing the coordinates from x to y and y to x. That's why that works. Okay? All right, now we're going to do the same kind of stuff with the inverse tangent. And then we're going to move on to some different things. And I think all I did in your handout is I gave you what the graphs of the other inverse trig functions look like. So let's do 2 things on this. Let's look at inverse tangent of 1. And while we're at it, let's go ahead and look at inverse tangent of negative 1. Okay, and this is going to work a whole lot like the sine. So this is the same thing as tangent theta equals 1. You want to go ahead and write that down like that. And then write this one as tangent theta equals negative 1 like that. Okay, now you can process this in your head okay. First of all, if you have a positive, you're going to be in this quadrant like that. If you have a negative, it's going to work just like the sine. You're going to have a negative angle down in quadrant 4. Okay? All right, so let's look at the unit circle. So remember, the tangent's y over x. Okay, where is y over x equal to positive 1? At pi over 4, right? Y over x is 1, agreed? So that means the inverse tangent of 1 is pi over 4. Remember, you only get one answer to these problems. So that one would be theta equals pi over 4. Okay? Now, we want to look down here now, okay? Where is where is y over x negative 1? Down here. Yeah, you have to say negative pi over 4. So you can't say 7 pi over 4. You know right there y over x is negative 1, but 7 pi over 4 is not within the boundary of the inverse tangent. So just like the sine, what you have to say here is you have to say theta is negative pi over 4. Okay, a tangent is an odd function. Now that's why you're getting one positive answer and one negative. Okay, that's how that works. All right, so it's very similar to the inverse sine. Okay, let's look at a few more of these things here. And this one right here, when you look at this is an arctangent of negative square root of 3 over 3 like this. So first of all, rewrite this as tangent theta equals negative root 3 over 3. Okay, like that. So the first thing you got to notice is since this is a negative, that means your answer is going to be down there. Okay, on an inverse tangent, you don't look there and you don't look there. You only look in quadrant 1 and 4. Okay, so here's the way I look at this. You can do this several ways too. Okay, since that has a square root of 3 in it, it's pretty obvious it's either going to be that or that, right? Agreed? Because those are the only two things that have a square root in them. So what you got to do in your mind is you just got to do y over x. This thing right here is in a rationalized form is what it is. So we can just try either one and see which one works. So if I was to take this one right here, let's see if that works. Okay, if you just did negative 1/2 over root 3 over 2, well, the 2's would cross out. You'd be left with negative 1 over root 3, right? Now, how do you rationalize that denominator? You multiply by root 3 over root 3, and then you would get what we have anyway, right? So it's got to be one of those two. In this case, it's going to be this one, but you don't give 11 pi over 6, you give what answer? Negative pi over 6, right. Okay, so the answer to this problem is going to be theta equals negative pi over 6. Okay, see, that doesn't match up as quickly and automatically as the inverse sine and cosine does. You have to just do that ratio of y over x. And it's got to be one of the two if it's got a square root of 3 in it, right? So one of them's got to work, okay? That's how I do that, okay? All right, let's look at inverse tangent. Did we already do? I thought we did one. Didn't we do that on the last page? I thought we did anyway. Maybe not. Yeah, we did. Okay, so this one goes like this. Let's just review this real quick. So you want to write this down as tangent theta equals negative 1. Okay, so again, it works like this. If you're doing an inverse tangent of a negative number, where are you? You're in quadrant 4, and you have to give a negative answer. So what's the answer to this one? Negative pi over 4, right? Okay, that's where y over x is negative 1. Can't give that answer because it's out of range. You have to go clockwise to give negative pi over 4 like that. So that would be theta equals negative pi over 4. Okay, like that. Okay? All right. The next one I guess I already did, so I'm not going to do that one. I just wrote that down twice. I don't know why I did that. So let me show you something real quick back on the calculator. And this is also sort of helpful to show students what happens on this. What I'm going to do on this is I'm going to do inverse tangent of a positive number like, and it doesn't matter what it is. You can do an inverse tangent of any number. So let's do the inverse tangent of 2. We got that, okay? Now, if I do the inverse tangent of negative 2, what do you suppose is going to happen? I get that. See, the inverse sine and inverse tangent work the same way. Does that make sense? One of them's a quadrant 1 answer. The other one is a quadrant 4 answer, but it's a negative angle. That's how inverse tangent and sine work. And I'll do the cosine one more time. If I do the inverse cosine of 0.5, that's a unit circle thing. That's 60, right? If I do the inverse cosine of negative 0.5, it's going to take you to quadrant 2. So it gives 120. Does that make any sense? Okay, so it's all about those ranges is what you're doing. And every inverse trig function has its special definition and some range that you have to follow. Okay, your calculator is programmed to always do that correctly. Okay, okay, so let's do this. We'll do a couple of more things with our calculator. So the domain of the inverse tangent, if you go back and look at your graph that we did, the domain was all real numbers. And then the range and interval notation is parenthesis negative pi over 2, pi over 2. You use parentheses because the tangent is undefined at pi over 2 and negative pi over 2. That's why. Okay, now we're going to focus on calculator a little bit. So like on a future exam, I always give students problems like this and they always go bad. Okay, so I'm going to try to make sure that you know how to do this right. your calculator, unless you have the fancy 89 or the Inspire, doesn't have cotangent, secant, and cosecant buttons. So what I'm going to do is try to show you carefully how you do this on your calculator. Because when you're learning this, students a lot of times do this totally wrong. So on this 24, what I want you to do first of all is I want you to rewrite this as cotangent theta equals negative 0.5065. Please write that on your paper. That's important. If you do that, then the likelihood of you getting this right on your calculator is high, okay? Now, you don't have a cotangent, but you have a tangent, right? So tell me how you change a cotangent into a tangent. What did we learn? You do the reciprocal, right? All they are is reciprocals, okay? You don't have to use 1 over tangent. You can just do the reciprocal of that like that. Okay, so the way you're going to put this in your calculator is you're going to do like this. If you're doing an inverse cotangent, and you want to get this written down so that you know how to do this, you're going to do inverse tangent of, and you got to have the negative in there somewhere, so just do negative 1 divided by 0.5065. That's how you do that. Now, to remember that, I try to get students to do it this way so that they can reason it out if they forget. So write it that way, then change it into a tangent. Now you're going to do inverse tangent of that. Does that make sense? Okay, because you don't have an inverse cotangent if you've got a TI calculator, one of the older ones, unless it's an Inspire or something. So it's going to go like that. So what I'm going to do on this one is I want the answer on this. Let's do this. I didn't tell you if I want it in radians or degrees. Let's just do radians on this. So you'd have to be in radian mode. If I wanted you to give me a degree answer, you'd have to be in degree mode. So I'm going to go to radians, and then I just put it in like this. I go inverse tangent of negative 1 over 0.5065, and then we'll round it off to whatever my handout says, 3 decimal places. So that's going to be written as negative 1.102 like that. Okay, so see what you're doing is like that. You're doing the inverse tangent of the reciprocal of that number. Now, this is what students do all the time. Watch this, and you might make a note of this. What students do most of the time on this problem, and it's wrong, is they will go inverse tangent of negative 0.5065, like that, and then they'll take the reciprocal of that number, which is totally wrong. So if you did 1 divided by negative 0.4688 and all those decimals, you get something totally different. Okay, so never do it that way. Always do inverse of 1 over that number. Okay, don't do the inverse and then take the reciprocal. You got to do this in the right order. It won't work. That's what students do wrong all the time on that. Okay, now let's do the next 2 here, because I've kind of shown you how to do this now. So on 25, let's write that as secant theta equals 1.2421 like that. Okay, which trig function is the reciprocal of the secant? The cosine is. So change it into cosine of cosine theta equals 1 over 1.2421 like that. And then you'll put this in your calculator like this. And you can write this down if you want to. We just go inverse cosine of 1 over 2.421 like that, and that'll give you the answer. Okay, I'm just doing this in radians, so that is 1.145 if I round that to 3 decimals, like that. Okay, right? You guys got it?
2 instead of 1.
What's that?
So on the bottom, wasn't it 1.2? And you get 2.4.
Oh, I put that in wrong, didn't I? Oops. Okay. I typed it in my calculator wrong. Let me try one more time. Okay. So we're going to go inverse cosine of 1 divided by, put the number in wrong, 1 divided by 1.2421 like that. Have I got it right now? Okay, there we go. So that's 0.635 like that. Okay, that's the idea. Okay. Now the next one, you can, once you get the hang of this, you can just, okay, on the inverse cosecant, what you're going to do is inverse sine of 1 over 4.1999 like that. Okay, but don't get that backwards. Have some sort of strategy for being able to figure this out. You don't want to mess up on this. So I'm going to do inverse sine of the reciprocal of that number. There are going to be times when you're going to get something that's undefined, but it shouldn't be on this one, I don't think. Okay, so that's going to give, in radians, 0.240 like that. Okay? All right, so my recommendation when you do this on a calculator is write them like I did there. That'll help you remember how to do that. Okay, does everybody follow that okay? All right. Okay, now let's finish up with a little bit of this composition stuff. These problems right here are designed so that you don't even need the unit circle. So I don't really need that on here. What we're going to do on this one is we got two things. We're doing the cosecant of the inverse sine of something. And you just follow this analysis in a certain way. Ultimately, what you're going to do on this problem is if you're doing a cosecant, what I like to have students do on this is I like you to just kind of look at, this is really saying the cosecant of theta, that's what we're trying to find, where theta is equal to the inverse sine of 3/5. So let's write that down first. So we're not going to, if you do the inverse sine of 3/5, you're not going to find that on the unit circle. You would have to do the calculator, but we can do this problem calculator free if we do this. So first of all, what is the definition of a sine? A sine is y over r, right? So that means if I'm asking for the inverse sine of 3/5, what you really have, and I want you to draw a little diagram down on this, is this. Okay, if you're doing an inverse sine, you're going to be either in quadrant 1 or quadrant 4 based on that range. So let's go through and let's just kind of put a point in there and do a little triangle on this like this. So y is 3 would be that. R is going to be 5 like that. That information comes from the definition of the sine, right? That's what that is. So we have r is 5. We have y is 3 like that. Okay? Now, what we're going to do on this problem is, this is supposed to say the range. I forgot to change that. The range of the inverse sine is negative pi over 2 to pi over 2. And we are in quadrant 1 on this problem. The reason we're in quadrant 1 is because that's a positive number right there. Okay? That's what forces that to be in quadrant 1. Okay? Now, what we're going to do is we're going to find the cosecant of that angle right there. So what's the cosecant's definition? It's r over y, right? It's just the reciprocal of the sine. So in this problem, what do you get? You get r is 5, y is 3, so that means the answer to this problem is 5 over 3. Okay, because we're doing a reciprocal of that sine, so that one would be 5/3 like that. That's the answer to the problem. Now that's the analysis that you go through on that. Is this thing right here, the key to this problem is I've given you two variables. I gave you y and I gave you r. I didn't have to find x because the cosecant doesn't require that you know x. Okay, does that make any sense? Okay, I'll do like a couple more of these to finish this up. You have to think through these a certain way. Okay, so let's do this one. First of all, we're going to figure out what sine of theta is. And what this means is you want to write this down. That means that theta is equal to the arctangent of negative 2. Okay, now I'm going to put that negative 2 over 1 because that's going to give me two variables. Okay, you're always going to know 2 of the 3 of x, y, and r. Okay, what's the definition of a tangent in terms of x, y, r? It's y over x, right? Okay, so that means if I'm asking for an inverse tangent, then the y must be that, and the x must be this. But we don't know which is negative. We really don't. You have to reason that out here. Okay, so first of all, what you learned here is the range, and this is something we went through today, the range of an inverse tangent is parenthesis negative pi over 2 to pi over 2. Okay, so since that's a negative, that's going to take you to quadrant 4 like we learned when we were dealing with the inverse tangent, okay? I find it very helpful to draw pictures on this. You don't have to, but let's do that. So since we're in quadrant 4, we're down here somewhere, and we're going to make like a triangle up to the x-axis like that. Okay, so y is this value. Would that be logical that that's negative 2? Yeah, because you're down, okay. X is going to be 1. Is that logical that that's positive 1? Yes, okay, because you're over to the right. Okay, so what we have to do on this is figure this radius out if we need to. So what we conclude from here is x is 1, y is negative 2, and then you can find r by doing the Pythagorean theorem because you're going to need it. Okay, so let's do that. We know that x squared plus y squared is equal to r squared. So let's see, x is 1, y is negative 2. So we're going to do the Pythagorean theorem to find that r value. So that's 1 plus 4 equals r squared. So that's 5 equals r squared. So what's r? Square root of 5. Okay, so this is that triangle stuff that we've done before. Okay, so really on these problems, if you can figure out x, y, and r correctly, then you got it made. So what are you doing? You're finding the sine of that angle theta. What's the sine's definition? Y over r. So that means that the answer to this problem would be y, which is negative 2 over r, which is root 5. And then you just rationalize the denominator. So the final answer to the problem would come from that rationalization like that. So the answer to this problem would be negative 2 root 5 over 5 after you rationalize that, like that. Okay? And that would be the idea. Now, before I let you go, I'm going to show you something on your calculator with this problem. This problem can be checked on your calculator, by the way. What I'm going to do on this one, it doesn't really matter what mode you're in, but I want to show you how you can check if you're right. So I'm just going to go sine of inverse tangent, an arctangent's an inverse tangent, of negative 2. So I can put this in like that, and your calculator just gives you decimals, right? Now take the answer that we got. The answer we got was negative 2 times the square root of 5. I got to get out of that radical, then divide that by 5. Let's see if we get the same answer. What in that? Isn't that amazing? Okay, you can tell you're right. You want to learn how to do that analytically. But you get your calculator out and tell if you're right or not. Okay, it all checks. So when you're doing these problems, the key thing is pay attention to the range of whatever that inverse is and find x, y, and r, then you got it. Okay, so you have to put that in exactly like that. And it doesn't matter what mode. If you're in radian mode or degrees, you get the same thing. Okay, it works out. Okay? All right, so that wraps up for today.